Okay, welcome to this next video, and we're going to be talking this time about place values and relational symbols. So firstly, I just want to draw your attention to quickly, you'll be seeing this a lot in our videos, this idea of a learning goal. Okay, so we're using these to sort of set at the very start what we are trying to achieve this unit. Okay, now you see this learning goal turn up a lot, so students will be able to solve problems involving comparison, addition and subtraction of integers. Okay, and what you'll also see is I'll be able to. So these are the things that you want to be able to do once you've sort of mastered this content. Okay, help you to get an idea of, do I understand this? Okay, so you'll want to be able to state the value of a given digit in a number, write a number in its expanded form, and place a set of numbers in ascending or descending order. Okay, so that's what you're going to want to be able to do once you've sort of finished this video and gone through the exercise stuff. Okay? Right, we'll have a look at a couple of our key ideas. So firstly, we use something called the decimal system, and you might have heard this before, the decimal system. I'm going to try and bold words in our key ideas and things if it's a term that's sort of special or you haven't heard it before, hasn't been mentioned, okay, or it's a particular thing that you need to remember what it means. Okay, so decimal system comes from that idea of decades, just means 10. Okay, and the reason why we use the decimal system is because we have 10 fingers. Okay, it allows us to count things easily and works very well for us. There's been a lot of other different types of number systems used, counting in sixes, counting in 60s, all sorts of stuff. Counting in twos is what our computers use and things, but for us it is the decimal system. Okay, and in the decimal system, the place of a digit corresponds to the value that that digit carries in that particular number. Okay, now some of these definitions might sound a bit weird and long-winded, but it's just sometimes hard to put in words a mathematical understanding. But it's very important that you learn how to do that, because being able to verbalize something more abstract like numbers does help your mind to be able to understand it a little better. Okay? And the places in those numbers correspond to a base of 10. Okay, so a base of 10 means, for instance, you might have seen things with powers, we'll be looking at them later on, but let's just say that you had 10 raised to the power of 3. Some of you might already know that that is the same thing as 10 times 10 times 10, right? The fact that this thing here is a 10 here, that means it's a base of 10, okay? So as we move up our numbers, the digits in a number, so from this 3, 1, 7, 4 and 2 in this 24,713 number, each of these is a different base of 10, and I'll show you what that means in a moment. Okay, so we'll just scroll down here. So let's have a look at this one, this number. Now you might have known this number here, so 3, this column, you've probably seen this as the ones column, okay, or units works fine as well, okay. This one here would be your tens, this one here would be your hundreds, this one here is your thousands, and this is your 10,000s. Okay, now what this means is, so let's look at this 10 one here. Okay, so this means 1 times 10. Okay, we're okay with that? Right, this, we're in hundreds now, so this means 7. Well, I might write that a little smaller, so let's go here, 7 times 100. Okay, but we can also write 100 as 10 times 10, which can also be written as 7 times 10 squared. Okay? This one here is 4 times 1,000. Okay? But 1,000 is 100 times 10. So we could write that as 10 times 10 times 10, which is 4 times 10 to the power of 3. Then up here we have 2 times 10,000, But you might be noticing the pattern here. We can write that as 2 times 10 to the power of 4. So you might be seeing we have a 4, 3, 2, which means that here is going to be a 1, okay? And this is an interesting one. 3 times 10 to the power of 4, 3, 2, 1. This is 0. That might seem weird to you that we can raise something to a power of 0, but we'll talk about that later, okay? So for the moment, we're just going to get you to roll with it, okay? Right, so we can also write numbers in their expanded form, okay? So this looks like if we wanted to write the number 713 in expanded form, that means we'd say that's the same as 7 times 100 plus 1 times 10 plus 3 times 1. Okay, so that's the expanded form of a number. Okay, that's all that means, is just to get the number and break it up into its little pieces. Okay, now the last thing I want you to look at for this video is this idea of in maths we can use these things called relational symbols to describe how one value is related to another. And this is really important that you realize that these are relational symbols. They're not actually operators. They don't tell you to do something. So you might have seen in the past something like 4 plus 3 equals. And then usually in a textbook or a workbook or something, you'll have a line here, a mysterious line, or maybe a dotted box or something. And you're saying, oh, I've got to do something, right? This equals sign here is telling me to do this, and then chuck the answer in there, okay? Now, that sort of works if all you think about maths as being is just a set of calculations you do, but that's not what mathematics is about. Mathematics is a lot about looking at patterns and the way things are related to each other and linked in and how they're different, okay? So we use these things called relational symbols to describe how one value is related to another. Okay, so this thing here, the equal sign, what I want you to think about it meaning is it means is the same as. Okay? Okay, is equivalent to, or is the same as, has the same value associated with it, okay? So 4 plus 3 is the same as 7. Okay, it's not 4 plus 3 equals 7 necessarily. I just don't want you to think about equals as telling you to do something, okay? Right, some of the other ones you'll see, you might be familiar with them. Okay, so that's our equals sign, is the same as, I'll write equals here. Okay. You'll also need to be familiar with the idea of our greater than symbol and our less than symbol. So is greater than and is less than. Okay? And we also have these ones here. So this means is greater than or equal to. And this one means is less than or equal to. Okay? And finally, yeah, I suppose oh no, 2 more probably. We're going to use, you'll be seeing this one, which means is approximately. Okay, so we use that when we make an estimate of something, when we don't need the perfect value necessarily. Okay, and lastly, a very important one is this one here, which means is not equal to. Okay, or is not the same as. Right, just some quick examples of seeing how these might be used. So 5 is greater than 3. Okay, 1 is less than 736,522. Let's see. 5 is also greater than or equal to 2. 2 is less than or equal to 2. Okay. Which seems a bit weird to write, but I just wanted to show you how those symbols can be used. Let's look at this approximately. So maybe 56 plus 9 is approximately 70. Okay, it's getting close to 70. So we can write that it's approximately equal to 70. Okay, this is not equal to, maybe 7 plus 20 is not equal to 9.3. Okay, so that's how we use those symbols. They're true and false values. They're sort of set in nice and hard to say how one side of something relates to the stuff that's on the other side of the symbol. Okay, so have a go at the exercise if you want to. Otherwise, I will see you in class and we'll have a talk a bit more about this. Thanks.